In this video, we are going to demonstrate a standing waves on a rope. Now, this picture shows there is a rope connected to a boundary at one end like this. When a wave is generated from the other end, as you can see, a wave generated and propagated along the rope like that way. So this wave is called incident wave to this boundary. You can see here this wave is traveling to the right side towards the boundary. That is why this wave is called incident wave. This wave hits the surface at that point and just being reflected with this 180 phase change and creating another reflected wave going in the other direction as shown. So the reflected wave will go in the opposite direction like this. Now you can see the actual motion of the rope has to describe all two motions, all two waves at the same time. Therefore, the actual wave has to move according to their resultant wave shown by this black color one. Now you can see when this time is stopped and the wave is fixed, the resultant wave at a given point is found by the superposition of these two waves. Now if you think a particular point somewhere here, you can just see that the incident wave function is with this much of height and the reflected wave function at the same point is that much of height, that is in the negative direction. The resultant wave function at the same point is given by the superposition, meaning that adding them algebraically. So you can continue this same argument for all the points of the rope. Just take the actual wave function, this wave function, by adding them algebraically, right? So now we can remove these two wave functions, incident and reflected, by checking them how the actual wave will be moved. Let this wave moves again. Now you can see here, now this incident wave is being removed, and then the reflected wave is being removed. Now you can see that this remaining wave function is the resultant wave function of the rope, and this rope has to oscillate in this accordingly. So this is what we call the resultant wave or the standing wave. All the wave natures, the standing wave natures, can be seen according to this motion of the rope. The places somewhere has no oscillations, those locations are called node. In the other location here, the particle oscillation takes place at the maximum amplitude. Those kinds of oscillations are simple harmonic, and this location is called antinode. So the wave pattern does not move in the standing wave, and therefore this wave is called standing or stationary. So let this incident wave is being generated like this, and reflected wave like that, and the all together form a resultant wave like this. Thank you very much.